Okay, hello students, my name is Theodore. Today we'll start Unit 2 of grade 11 physics. Therefore, we will see about vectors. First, let us start from types of vector. Before starting types of vector, let us see the basic vectors. Let us recap and how we can represent vectors. Let us recap. First, all physical quantities are either what? Scalar or vector quantity. And the difference between vector and scalar is that a vector quantity has both magnitude and what? Direction. But a scalar quantity has only what? Magnitude. Therefore, if it has magnitude and direction, it is a vector. If it has magnitude only, it's what? Scalar. All quantities have a direction associated with them. This is a vector. For example, the displacement 6 km to west. This has a magnitude and what? Direction. Therefore, this one is a vector. An acceleration of 9.8 meters per second square down. Down is the direction, and this one is what? The magnitude. Therefore, if it has a magnitude and direction, it's what? A vector. For scalars, has a magnitude only. For example, mass, energy, and so on. Therefore, see, these are some vector examples, and these are some scalar quantity examples. Distance, speed, mass, energy, and temperature are what? Scalar quantities. But here, force, displacement, velocity, velocity, acceleration, momentum, and so on. There are so many. Among these are some examples of vector and scalar. And representing vectors. We can represent vectors in three ways. The first one is by an arrow. When we express vectors by an arrow, the point or the head of the arrow indicates what? Direction. And the length of the arrow indicates what? The magnitude. Therefore, when we represent by an arrow, the head of the arrow indicates the direction, and the length of the arrow indicates the magnitude. And the second one is representing vectors by writing an arrow above the letter. For example, force is a vector. After you write the symbol F, you must write an arrow above the letter. This indicates that this F is a vector. This one is the second types of representing a vector. And the third one is by bold lettering. For example, you can also express this force by bold writing of F. You can bold F and it's written just like this. If you make bold the letter, that indicates that the vector, that symbol stands for a vector quantity. Now let us see types of vectors. The first types of vector, there are several types of vectors. Among these, we will see some of them. The first one is position vector. A position vector represents what? A position of an object in relation to what? Another point. For example, distance of bearing. This one is polar form. This one is what? Component form. In distance of bearing, the angle is measured from the vertical, and this vector is expressed from relative to what? Point B. Therefore, if it is expressed relative to another point is expressed as position vector. We can express this position vector in three ways: in distance and bearing form, and in polar form, and in component form. And the other thing is unit vector. A unit vector, from the name, it said that unit, that means it has a magnitude of how much? 1, and a direction of, it has a direction as well as what? A magnitude of 1. Therefore, a unit vector is a vector with length equal to how much? 1 unit, or a magnitude equal to 1 unit. Therefore, we have three unit vectors, I, J, and K. I has a unit of 1, and the direction is in the X, and J is a unit of 1, and its direction is what? In Y. And K is, its unit is 1, and its direction is what? Z. Therefore, I is in the X axis, and J is in the Y, and K is what? In the Z direction. And they have a unit of what? 1. The other thing is collinear vectors. When we say two vectors are collinear vectors, you must take care of this definition. When we say collinear, they are what? One-dimensional. That means they are parallel and they are lying in the same line. Therefore, to be a collinear vector, they must be what? Parallel to each other and they act along the same line. They can be in the same direction or opposite, but they must be parallel and they must lie in the same line. For example, if we draw vector 1 and vector 2, these two vectors are not collinear vectors. They are parallel, but they are not lying in the same line. But if this vector is such a like or such a like, these three vectors are what? Collinear vectors, because they are lying in the same line, as you see, in the same line, and they are also what? Parallel. Therefore, collinear vectors are a vector that lying in the same line as well as parallel. And collinear vectors are one-dimensional since they are parallel or lying in a straight line. They are one-dimensional. Coplanar vectors. The third one is coplanar. Coplanar vectors are vectors in the same what? Dimensional planes. Here we have three planes. This plane is xz plane, and this plane is yz plane, and this plane, the front plane is xy plane. This plane is xy plane, and this plane is yz plane, and the top plane is xz plane. If the vectors are lying in xz plane, if two vectors are lying in xz plane, they are coplanar vectors. And if they are lying in yz or xy plane, they are what? Coplanar vectors. Therefore, to be a coplanar vector, they must lie in the same or similar plane. Okay. The other thing is resolution of vectors. Resolution means resolving a vector. Resolving means subdividing or dissociating a single vector into its component vectors. We have two types of component vectors, that is vertical and horizontal component. Therefore, to read this, vertical component is equal to what? Hypotenuse times sine theta, and horizontal component is equal to hypotenuse times cos theta. By using this equation, we can resolve vectors. We use trigonometry to do this. The other thing is Pythagoras theorem. According to Pythagoras, for right angle triangle, the sides of the triangle, a square sum gives us what? The square of the hypotenuse. Therefore, a square, the hypotenuse square, is the sum of the sides square. Therefore, b square plus c square. This one is Pythagoras theorem. The other thing is vector addition. You have learned this on grade 9 in detail. We can add vectors depending on their direction. Depending on that, we can divide vector addition into 3. The first one is depending on their direction, we can divide into 3. The first one is if the vectors are parallel vectors. If the vectors are parallel, we can take what? The algebraic sum, and by taking into account their direction, we can take the sum of the vectors. The second one is if they are perpendicular vectors. To do this, to get the vector sum of perpendicular vectors, we use what? Pythagoras theorem. The hypotenuse, let us say this one is vector 1 and this one is vector 2, and these two vectors are perpendicular vector, and this hypotenuse is what? The resultant or the sum of the two vectors. And to get the angle, we must use or apply tan theta. And if they are not parallel and perpendicular vectors, we can use resolving technique or scale diagram. You have learned this on grade 9. In component form, if we have a vector a, ax in the I, a y in the j, a z in the k, and another vector b, b x in the I plus by in the j plus bz in the k. This one is vector b. If you are asked to determine a plus b, always you must add the similar unit vectors. Therefore, ax in the I, bx in the I. These two are added. Therefore, ax, bx in the I. And ay in the j and bz in the by in the j is also added separately, and az with bz, because they have what? K direction. Therefore, you must add similar directions separately. And also, if it is the vector is multiplied by some constant, you must multiply each unit vector or each separately by that constant. For example, c is a constant and c times a, and this c multiplies each of them. And if you are asked to determine the magnitude for this vector a, the magnitude is equivalent to under radical of what? The square of ax plus ay plus az is the magnitude of the vector. And as we said before, ax means the horizontal component, ay means the vertical component. Therefore, the horizontal component is a is the hypotenuse times cos theta, and ay is the vertical component, therefore the hypotenuse times sin theta. As you said, the magnitude is the square of ax plus ay, and tan theta, to determine the angle we use ay over ax. That means vertical over horizontal. The other thing is multiplying a vector. Multiplication vector has two types. The first one is dot, and the second one is vector or cross product. Dots or scalar product. When you dot or scalar or multiply two vectors by dot product, our final answer is always a vector. Because of a scalar. Because of this, we can say this dot product is what? A scalar product. Therefore, if a is a vector and b is a vector, a dot b, our final answer, this one is what? Scalar. Therefore, the dot product of two vector is scalar. Or the scalar product of two vector is what? Scalar. Therefore, a dot b is equal to magnitude of a magnitude of b times what? Cos theta or phi. And this theta is the angle between the two vectors, vector a and b. This one is the general equation which we use to multiply two vectors by using dot product. But if they are in terms of component, always they multiplied the similar directions. That means if ax is equal to a is equal to ax in the I plus ay in the j plus az in the k, and vector b is equal to bx in the I plus by in the j plus bz in the k. And if you are asked to calculate a dot b, as you see here, ax in the I is only multiplied with bx in the I only, because if you multiply this with this one, that means ax in the I with by in the j, I and j are lying in different directions. I is in x direction, j is in y. Therefore, the angle between them is how much? 90 degree. And cos 90 degree is 0. Therefore, it cancels out. Therefore, as a general equation, if it is a dot product, you must dot or multiply the similar direction. I with I, j with j, and k with k. Therefore, I with I times I squared, that is 1. And our final becomes ax bx, and ay with by, and az with bz. እዚህ ጋር ምን ማለት ነው? ሁልጊዜ ዶት ፕሮዳክት ሲሰሩ የአይን ከአይ ብቻ ነው ዶት የምናደርገው ወይንም የምናባዛው ax ኢንደ አይን ከbx ኢንደ አይ ብቻ። ምክንያቱም ax ኢንደ አይን ከby ኢንደ j ብናደርግ 0 ነው የሚሆነው። ምክንያቱም i እና j i በx አክሲስ j ደግሞ በy ነው። ስለዚህ ኤክስ እና ዋይ መካከል ያለው አንግል ስንት ነው? 90 ዲግሪ። እዚህ ጋር ደግሞ ዶት ፕሮዳክት ላይ የምናስገባለን ተባብለናል። ኮስ ቴታ ኮስ 90 ምንድን ነው? ሁልጊዜ ዜሮ ነው። ስለዚህ ይሄም በዚህ ቢባዛ ዜሮ ነው፣ ይሄም በዚህ ቢባዛ ዜሮ ስለሆነ እሱን በሙሉ እንተወዋለን። ስለዚህ ስናባዛ የሚቀመጠው የትኛው ብቻ ነው? ሲሚላሮቹ አይን ከአይን ጄን ከጄ ኬን ከኬ ማባዛት። እዚህ ጋር ግን አይ እና አይ ሲባዛ አይ ስኩዌር ስለሆነ የሚሆነው አንድ ነው። ስለዚህ አይ ዶት አይ ኢዝ ኢኳል ቱ ጄ ዶት ጄ ኢዝ ኢኳል ቱ ኬ ዶት ኬ ስንት ነው? አንድ ነው ማለት ነው። ስለዚህ ይሄን እንደ ጀነራል ኢኩዌሽን መውሰድ እንችላለን። እዚህ ጋር ግን ጥንቃቄ ማድረግ አለባችሁ። ዩኒት የለውም፣ ዳይሬክሽን የለውም። ምክንያቱም ዶት ፕሮዳክት ፋይናል አንሰር ኢስ ዋት ስካላር ስለሆነ ማለት ነው። ሁለተኛው the two vectors are perpendicular. If they are perpendicular, their scalar product is what? 0, because the angle between them is 90 degree, cos 90 is 0. It makes 0. Therefore, if you get the dot product of two vectors equivalent to 0, this indicates that the two vectors are what? Perpendicular vectors. The second one is vector product. Vector product. From the name, the cross product of the two vector is what? Vector. It has what? A direction. A direction. And let us say vector A and B is a vector, C is whose magnitude. Therefore, the magnitude of the two vector A cross B is equal to magnitude of A, magnitude of B times what? Sine theta, and we have a unit vector n. This unit vector n is the direction of the cross product. And always A cross B, the cross product result is perpendicular to both A and B. እዚህ ጋር በደንብ ማወቅ አለባችሁ። A cross B ሰርታችሁ የምታገኙት ቫልዩ አለ። የዛ ቫልዩ ዳይሬክሽን ማለት እዚህ ጋር የምናስቀምጣት ዩኒት ቬክተር n ነች። and ሁልጊዜ የክሮስ ፕሮዳክቱ ዳይሬክሽን ኦር የክሮስ ፕሮዳክቱ ዳይሬክሽን ከእያንዳንዳቸው ያ ማለት ከኤም ጋር ከቢም ጋር ከቬክተር ኤ እና ከቬክተር ቢ ጋር ክሮስ ያደረግነው ኤ እና ቢ ስለሆነ ማለት ነው። ከቬክተር ኤም ጋር ከቬክተር ቢም ጋር ይሄ ኤ ክሮስ ቢ አድርገን የምናገኘው መልስ ፐርፐንዲኩላር ነው። ስለዚህ ለሁለቱም ፐርፐንዲኩላር ይሆናል ማለት ነው። therefore as you see A cross B, if it is the C is here, C is equal to what? A cross B. Therefore A cross B is equal to C, and this C is perpendicular to what? Both. Perpendicular to both. And A cross B is not equivalent to B cross A. It's equivalent to what? Minus B cross A. It has a minus sign. It has a minus sign. But in dot product, A dot B is equivalent to what? B dot A. It's similar. Doesn't have any change. But if you are asked to calculate A cross B and B cross A, the magnitude is similar, but the value, if it is positive, it makes negative, negative makes positive. Therefore, it has a minus sign. A minus sign. If let us say A cross B, if it is C, B cross A becomes what? Minus C. Minus C. It has a minus sign. And to do the cross product of two vectors, always use a determinant technique. Determinant of the two. And here we have a determinant. First, when you write this determinant, A cross B is equal to, first you must write I, J, K. And since the first vector is A, you must write the value of A in the I, and the value of A in the Y, and the value of A in the Z direction. And the second vector is B in the X, B in the Y, and B in the Z. If it is not given, you must write 0. For example, if it is vector B is equal to 2I plus 3J, there is no Z. This indicates that plus 0 in the K. Therefore, you must add 0 in the K. And then the first I is positive and J is what? Negative, and K is positive. First, you must cancel the first row and the first column. Then we have left with what? AY, AZ, BY, BZ. And you must multiply crisscross AY with BZ. AY times BZ minus AZ times what? BY. this is, we cancel I, therefore in the I. And the second one is what? Negative, therefore we make it what? Minus. We can make minus. Or by making plus, interchange. Let us see that. You must cancel the second. Let us see this in clear form. Let us see this clearly. Let us write first. We cancel for this. The first one is positive, therefore this one is equal to ay bz minus az by in the I. And then it's what? Minus, because j is minus, I is plus, and this one is minus, this one is plus. And we can cancel out the first row and the first column, the first row and the second column, and we have left with what? This and this value. Therefore ax bz minus what? Az bx, az bx. We cancel j, therefore it's what? In the j, and this one is positive, therefore plus. Then k cancelled, and ax by minus what? ay bx, and this one is in the k. Here az bx, but this one is what? Minus, and this minus multiplies this as well as this one, and when you multiply this, it becomes positive, and it becomes what? First. That means by making this plus, az bx minus what? ax what? bz. Therefore you can take this as a general equation, or for every equation by writing its determinant you can determine the cross product of the two vectors. This is all about vectors. Until next time, have a nice time.